Okay, today's lesson is on what happens when the molecules are getting rearranged. And by that I mean, can we classify the chemical reactions by what is occurring? Can we look at the equation and see what is happening? And we've already said through the law of conservation that in a chemical reaction, atoms get rearranged and they bond to other atoms in specific ways. And there are 4 ways that we're going to talk about that this can happen. The first way is called synthesis. In synthesis, you have 2 or more elements. So you're going to start with 2 reactants, and they are going to combine to form one product. So if I were you, I would highlight that one product once I get it written in my notes, because you can always identify a synthesis reaction because there is no plus sign on the product side of the reaction. There is only one reactant, one molecule that is there. And so when iron and oxygen combine to form rust, that would be synthesis. Some of you who are musical may have heard of a synthesizer. That is an instrument that can take many sounds and play it out of that one instrument. So you could have a guitar sound coming out, you could have a woodwind sound coming out, you could have a brass or a drum or a piano. So you can have multiple sounds coming out of one instrument. So you can identify synthesis again because there is only one product. In decomposition, it is the opposite reaction. So if synthesis is putting 2 or more things together to make one, decomposition is breaking down one molecule into its simpler products. So anytime something decomposes, it is breaking down. So in the example, potassium chlorate is breaking down to potassium chloride plus oxygen. So that oxygen molecule is breaking apart. So if I were you, I would highlight the one reactant or the one complex compound in that. So you can always identify decomposition because you're only going to start with one reactant. That is the key to identifying that equation. The next 2 are called single and double displacement. Now, I want you to think about this example. You and your best friend and her boyfriend decide to go to the movies on Friday night. You go to the movies. On Saturday, your best friend calls you and tells you that she and her boyfriend broke up after the movies. They had a big fight and they're no longer together. On Monday morning, you go to school and he comes to talk to you. Next thing you know, a week later, you and he are going out. Your friend has been booted out of the relationship. And that's really a silly example, but it does kind of give you a visual of what's happening in a single displacement reaction. You have one element reacting with one compound on the reactant side of the equation. So in my example, aluminum, the single element, is reacting with copper chloride, the couple or the compound. Once the reaction takes place, aluminum has kicked copper out of the compound. Copper is now all alone by itself, a single element. And aluminum is coupled or in a compound with chloride. And so on the product side, you have a new single element and a new compound. So you can recognize single displacement because you will have a single element plus a compound, and then you will have a new single element and a new compound on the product side of the reaction. In double displacement, it's a double date gone bad. 2 couples go to the movie on Friday night. On Saturday, the girlfriends call each other and say, "We broke up." Next thing you know, a week later, you have reformed as 2 new couples. So in the example I give you, sodium chloride and hydrogen oxide, or water, react. Hydrogen, one of the hydrogens, and sodium switch places. We've got 2 new compounds. we've got hydrogen chloride, and we've got sodium hydroxide. So everybody got a new partner. So you recognize double displacement by counting the compounds that you see. And in this case, you see sodium chloride and HOH, 2 compounds. And then on the product side, you see HCl and NaOH, 2 new compounds. So the double displacement is a double date gone bad.